Hello students, welcome all of you at AriserTalent. How are you all? I hope you are doing absolutely well. So, in our previous lecture, we have discussed about the classification of the bases and the conduction nature of bases also. Now, likewise the characteristics of the acid, we are going to deal with the chemical properties of the bases and the differentiating table regarding acids and bases in our today's lecture. So, our next topic will be the chemical properties of the bases. So, our topic is chemical properties of bases. So, in this topic, we will see the two reactions of the bases regarding with metals and non-metal oxides. We are considering the non-metal oxides because with the metal oxides only acids have a tendency to react. On the other hand, non-metallic oxides react with bases to give salt and water. So, we will see the reactions regarding this one by one. So, our first category is reaction with metal. So, some of the metals like zinc, tin and stannous is for tin, have the capability, and aluminium have the capability to react with the bases and form the corresponding salt in the reaction with the evolution of hydrogen gas there. Now, what happens in this reaction? I am writing the general representation here. So, the general representation will be any metal is going to react with base to give salt plus evolution of hydrogen gas. So, this will be the general representation for representing any equation that metal react with base to give the corresponding salt with the evolution of hydrogen gas in it. Now, let us take an example to understand this type of reaction. Example here is, I am taking a metal that is zinc. We are reacting zinc with sodium hydroxide, that is caustic soda, and what we are getting in the product side, we will get sodium zincate, that is a salt, that is Na2ZnO2 with the evolution of hydrogen gas in it. So, we can see here when some metal is going to react with base, we will get a corresponding salt, that is sodium zincate, with the evolution of hydrogen gas with it. So, you can see here, this is a general representation for the reaction with metal. Now I am considering the another metal, that is tin. So, tin is basically known as stannous. Sn is a metal, that is tin. Now, we are reacting tin with sodium hydroxide, that is base. Now, what we will get in the product side? Again, we will get Na2SnO2, that is sodium stannous with the evolution of hydrogen gas in it. Again, we have seen here when the metal react with base, the corresponding salt is obtained with the liberation of hydrogen gas in the reaction. So, bases generally show the reaction with the metals, and the reaction with the metals, they will form salt and hydrogen gas. So, this is generally the reaction with metals. Now, we are proceeding to our next topic, reaction with non-metallic oxides. So, our next topic will be reaction with non-metallic oxides. Now, in the category of the non-metallic oxide, what we are seeing here, the base react with non-metallic oxide to give salt and water. So, again I am writing the general representation of this equation here. So, the general representation will be non-metal oxide will react with base to give salt and water. So, in this equation, what we are getting only salt plus hydrogen gas. Now, in the second equation, what we are getting salt plus water. So, this will be the general representation for the non-metallic character. Now, what happens in this case? We will take an example to understand this. So, I am reacting carbon dioxide with NaOH. So, this will be our first example. Now, what we will get in the product side, we will get sodium carbonate, that is salt, with another byproduct, that is water. So, you can see that carbon dioxide is a non-metallic oxide and it is going to react with a base to give salt and water. So, generally we can write this is carbon dioxide, this is sodium hydroxide. These both will going to react and form sodium carbonate with the liberation of water as a byproduct. So, this will be the equation representation of the reaction with non-metallic oxides. Now, we will take another example here. What we will do here, we will take again NaOH and start reacting this NaOH with, firstly we have taken a carbon dioxide, now I am taking the sulfur dioxide, that is SO2. So, what we will get here, Na2SO3 with the liberation of H2O. So, in this equation, what we have seen here, again we have taken a base. This base is going to react with non-metallic oxide and the product obtained is salt plus water. So, this will be the reaction with non-metallic oxide, and these are the two general chemical properties regarding bases, that is reaction with metal and reaction with non-metallic oxides. Now, we are going to move with our next topic, but before you can copy it from here. So, now our next topic will be what is difference between the acids and base. Next topic is differences between acids and bases. Now, there is a tabular description to distinguish between acids and bases, and this question is very important from your exam point of view, that is what is difference between the acids and bases. This question can be come in your exam from many ways, like what are the characteristics of the acids, what are the characteristics of the bases, and the next question will be the difference between acids and bases. So, this topic is very important from exam point of view, not from the competitive exam point of view, only for your subjective papers. So, now we will learn a general description to distinguish about the acids and base. So, here I am considering acids, and in our next category I am taking bases here. So the first point that is used to distinguish between acids and bases are acids are generally sour in taste and bases are generally bitter in taste and soapy in touch. So our first point to distinguish acids and bases will be, first point is acids are sour in taste and for the bases I can write that bases are bitter in taste. So the bases are bitter in taste. So this will be the general distinguished point of acids and bases. Now we are moving to our next point. Acids dissociate to give H plus ions and bases dissociate to give OH minus ions. Our next point to differentiate between acids and bases are that they both will going to show a electrical conduction. So the third point is acids show electrical conduction bases also going to show electrical conduction. Next thing is acid lose its properties by reacting with base. It means they are going to neutralize each other and show neutralization reaction. So the fourth point to differentiate between acids and bases are acid react with base to form salt and water. This reaction is basically termed as neutralization reaction. This is neutralization reaction. Now bases again react with acid to form salt and water. So we can say that bases react with acid to form salt and water. Now again this type of reaction can be considered as a neutralization reaction. So this reaction is also a neutralization one. Now we have our fifth point to differentiate between acids and bases, that is regarding the color change. So both acids and bases will show a color change effect. So our fifth point will be they show color change and base is also going to show color change. Now we will take an example to understand the difference between acid and bases regarding the color change, and that is in case of acids and here in case of bases, what actually happens? If I am considering the litmus paper, so in case of the acid, blue litmus turns into the red one. So here if I am taking litmus, in case of litmus, blue litmus changes to red. But if I am considering the litmus in case of the bases, red litmus change to blue. Another example for defining the color change I am considering is phenolphthalein. So our next example is phenolphthalein. In case of the phenolphthalein, acids will not going to show any change. So we can say that acids will remain colorless. But if I am considering the phenolphthalein in cases of the bases, in case of the base, the phenolphthalein will changes into the dark pink color. So it will give dark pink color. So this is about the general points to differentiate between the acids and bases. Here I have discussed only the 5 points regarding acids and bases. We have many points to distinguish between acid and bases, and it can be returned according to the number of marks that this question contains. So if you want to copy it, the difference, please copy it from here. Now we are moving to our next topic, that we have discussed about the general description for acids and bases. Now we are on the theories of acids and bases. So our next topic will be theories of acids and bases. So in the theories of acids and bases, different scientists came and gave their different theories. So our first theory will be the Arhenius concept that we have already discussed in the starting of this chapter. So we have the 3 theories regarding the theories of acids and bases. Our first theory will be the Arhenius concept. Second one will be the Bronsted-Lowry concept, and the third concept will be the Lewis concept for acid and bases. So we have the 3 theories here. Our first theory is Arrhenius theory. The second theory regarding acids and bases will be the Bronsted-Lowry concept. And the third concept will be given by Lewis. So it is known as Lewis concept. So there are the 3 theories regarding acids and bases. So first we will deal with the Arrhenius theory for acid and bases. Then we will proceed to Bronsted-Lowry concept and Lewis concept. Now we are on the first theory of the acids and bases. Our first theory is Arrhenius theory regarding acids and bases. So the first category here is this theory was proposed by a chemist known as Svante Arrhenius between 1884 and 1887, and he probably said about the one thing about the acids and bases that we have already discussed here, that acids are the substance which have a tendency to release H+ ions in their aqueous solution, and the bases on the other hand are those compounds which have the tendency to release OH- ions. So Svante Arrhenius chemist Svante Arrhenius between 1884 to 1887 proposed this theory and he gave the two general descriptions regarding acids and bases. So firstly we will consider acids, and here we are going to discuss about the bases. So what Arrhenius proposed about the acids are those acids are those substances which have the tendency to release H positive ions. So acids will going to release H plus ions in aqueous solution, and on the other hand bases are those compounds which are going to release OH minus ions in their aqueous solution. So this is the two things about the acids and base we have discussed here, that acids will give H plus ions in their aqueous solution and bases will going to give OH minus ions in their aqueous solution. Now according to the Arrhenius concept, this will be the simpler definitions of acids and bases that we are going to understand with the help of an example. So here I am considering the example. Suppose we are provided with HCl. HCl on reacting with water dissociates into H positive and Cl negative. Similarly, if I am considering about H2SO4, H2SO4 will dissociate into 2H positive plus SO4 minus 2 ions. So you can see here on dissociation of hydrogen chloride and sulfuric acid, what we are getting in the product side, hydronium ion and hydronium ion, that is H positive ions. So HCl and H2SO4 are considered in the category of acids. Now we are moving to our next term, that are bases. Bases are those substances which have a tendency to release OH minus ions in their aqueous solution. So again we are taking example here. Suppose we have NaOH, caustic soda, it will dissociate into Na positive plus OH negative. Now I am considering the second example, that is caustic potash, that is KOH. KOH will dissociate to give K positive plus OH minus ions. So what we can see in this equation, OH minus ions are released in both the cases. So we can say that this component which have a tendency to release OH minus ions are considered in the category of bases. So you can see here OH minus ions are released in this equation. So Arrhenius gave this concept for all the acids and all the bases. So now this is all about the acids and bases. Apart from this, we have certain bases and acids also which will not completely dissociate into ions in their aqueous solutions. So these categories we have already discussed, that what are the strong acids and strong bases and what are the weak acids and weak bases. So these are actually the strong acids and strong bases. In the category of weak acids and weak bases, if I am considering about weak acid, so the example for weak acid will be acetic acid, and the formula for acetic acid will be CH3COOH. This will not dissociate into ions in the solution, so we can say that it will be either not dissociate or partially dissociate. Now we have another example for the example of weak base. For the weak base, we have a general example, that is NH4OH, which is basically ammonium hydroxide. So a question of 1 mark will be formed from here, that give an example of strong acid and give an example of weak base or weak acid, or any of the question can be arises from here. So this will be of the 1 mark question. If you want to copy it, please copy it from here. Now we are moving to our next category of the theories regarding acids and bases. Our second theory will be Bronsted-Lowry concept. So we are moving to our next category. Now we are on our second theory regarding acids and bases, and our second theory will be the Bronsted-Lowry concept. So the second theory is Bronsted-Lowry concept. So in 1923, after the Arhenius have given the general description about the acids and bases, Bronsted and Lowry give the extended definition or the modern definition for acids and bases in 1923. So what they said about the acids and bases, the substance which have a capability to donate proton are acids, and the substance which have a tendency to gain protons are known as bases. So what they said about the acids and bases? In 1923, J.N. Bronsted and J.M. Lowry proposed this theory. This theory is basically proposed by these two chemists, that is J.N. Bronsted and J.M. Lowry. Now, what they say about the acids and bases are, according to this theory, acids are those compounds which have the tendency to donate protons. So, acids are those compounds which can donate proton. And on the other hand, bases are actually those compounds which have a tendency to accept protons. So bases will going to accept proton. So they made the two general conclusions about the theory of acids and bases. Now we will take an example to understand this theory. So we have taken an example here. Suppose we have provided with HCl and HCl is going to react with H2O. Now, when HCl will going to react with H2O, what we will get in the product side? We will get hydronium ion plus Cl negative ion. Now, you can see in this equation, hydrogen chloride have a tendency to donate the proton, and this proton will be accepted by water to form hydronium ion. It means HCl is doing what? It is donating proton. And what water is doing here? Water is accepting proton. So that's why HCl will lose the proton and form chloride ion, and water will gain the proton and form the hydronium ion. So I must say the substance which have the tendency to donate the proton, that is HCl, is acid, and water is having a tendency to accept the proton. So we can say the water is a base. Now this acid is going to form H3O positive, and this water is accepting to form hydronium ion, and chlorine is liberated from this. So we can say that this is acid 1, this is base 2. this is acid 2 and this is base 1. So we can say that this is the acid base pair and this is the another acid base pair we have provided here. So we can say that this is one pair and again we have this two pair. So this is called the conjugate acid base pair and the another pair is known as the conjugate acid base pair. So what is actually the conjugate acid base pair? If the gaining of the proton and donating of the proton is done simultaneously, we can consider it as a conjugate acid base pair. So we can say here that this is the conjugate acid base pair. So this will be the conjugate acid base pair and we can write the general equation for the representation of the conjugate acid base pair. Suppose we have acid 1, this is going to react with base 2. What we will get in the product side? We will get acid 2 and what we will get here? Base 1. So acid 2 1 base 2, acid 2 base 1. So this acid base pair is known as conjugate acid base pair. And this is the another pair, we can also this pair as a conjugate acid base pair. So this is not only in the case of the hydrochloric acid, we have many more examples for the acids. Now this lecture is over for today. We will deal with our last theory in our next session. So thank you so much and have a nice day.